Reviewing rebar diagrams on construction sites has always been a time-consuming task for project managers. There is a need of an alternative method that would save time. Augmented reality in construction industry is the solution for this problem. After an introduction of Microsoft HoloLens, the concept of augmented reality perceived by an individual has been revolutionized. It has made placement and scaling of holographic representations much easier. Next generation augmented reality gaming has been made possible with advent of this technology. It provides a great experience for the viewer for looking recorded videos or movies and video conferencing. We tried to import an FBX file of a large-scale project of our industry partner into Unity. The import operation took about 3 hours to be completed. The import of an FBX file of a small-scale animation converts into an asset file of about 60 to 70 subparts, which can be imported easily. However, our large-scale project had an asset file of about 11,000 subparts. We performed a real-time spatial mapping simulation for the whole construction management lab at University of Michigan. The simulation recording generated a 3D mesh-like structure of the lab which could be viewed on the Windows device portal directed by the IP address of the HoloLens. The lab mesh file is then imported into the default Unity file, which is updated to convert into a solid building model. The building model is then imported into the Visual Studio, followed by releasing it into the remote machine with the help of the IP address. This resulted in a failed attempt since we weren't able to edit the mesh-like model in order to add the rebar. After the spatial mapping attempt, we tried to make the reinforcements in a BIM model of the construction management lab in Revit. We were successfully able to draft a 3D model of the project in this software. However, the FBX of the Revit model was not importing the reinforcement components inside the Unity. This led to a change in methodology to switch different softwares, and we chose SketchUp. We created the same model in the second software, and we were successfully able to import the reinforcement component inside Unity. However, on releasing the Unity file to the HoloLens, we realized that the import process was scaling down the model to an unknown value. Finally, we switched again to a software Rhinoceros, which did not cause any problems like missing building components in Unity or unknown rescaling when importing into the HoloLens. By adjusting the positioning of the model with Unity, we were able to align closely to the BIM model with the construction lab. For our final attempt, our team was successfully able to generate a 3D model with the reinforcement components of a space, plus import and view with the model in HoloLens. By going through the process of 3 different softwares to build a 3D model that included rebar components, we were able to determine which software imported all drafted components of the model, along with the methodology to align reinforcement model with moderate accuracy. While we are still having some problem with the accuracy of alignment of the rebar with the real world space, there are some advantages in incorporating augmented reality with construction industry, such as a decrease in number of RFIs, an increase in construction efficiency, as it allows for better scheduling of future work, reduction of material waste as well as errors in omissions. Additionally, it allows to share up-to-date design data with site teams. It tightens workflow integration and enables real-time collaboration.
We are Danni, Zeng,
Shreyas, Mishra,
and Elinge Ngongi from University of Michigan.